This lesson is going to discuss increasing and decreasing functions. We'll also talk about maximum and minimum of a graph of a function. So this should be relatively intuitive. Increasing means it's going to be going up from left to right. And if we are increasing, that also means that if we're going up, that means as we go along, those numbers have to get bigger and bigger. So if we apply the mathematical definition, that would mean that a function is increasing on an open interval, is what we're going to be looking at. If f of b is greater than f of a. So like I said, as we move along from left to right, the numbers have to get bigger and bigger, the outputs have to get bigger and bigger for any two input values. And again, where b has to be greater than a. So again, as we move along from left to right, those output values that we get when we plug those numbers into the function have to get bigger. This is going to be similar for a decreasing function. We are going to again be kind of going down from left to right. So again, on an open interval, if f of b is less than f of a, so again, as we go along from left to right, those numbers have to get smaller and smaller. For any two inputs, a and b, where again b has to be greater than a. So again, we're moving along left to right, b is over here, a is over here, and as we go along from left to right, the numbers are going to get smaller and smaller. So we can also discuss maximum and minimum, and when it comes to these, we can talk about relative or local. Those are the two words that we can use interchangeably. What that means is that it is in comparison to the points around it. So if you look at this graph here, our point -2, 4 is a maximum in comparison to the points next to it, but if you look over at the end of the graph, it goes up into infinity, so it's not a global or absolute maximum, which is our second definition there, if it's the highest point over the entire graph. So again, we have this difference between local and absolute or global. So a maximum or minimum, and we can group those two terms together and call them extrema or the extreme points. A function has a local maximum at a point x equals b if there exists an interval, we'll say from A to C, with A less than B less than C, such that, and I'll abbreviate there, for any interval AC, f of x is less than or equal to f of b. So again, this is kind of the math terms for all of this stuff. It's saying that if you've got this interval and you've got this point B somewhere in that interval, that when you plug in all of those values anywhere in that interval, those outputs have to be less than if you were to plug in b to that function. So again, that has to be the high point. Similar for minimum, the only difference is that f of x is greater than or equal to f of b. Again, every point has to be higher than our minimum. Again, absolute minimum and maximum are just going to be the max and min for the entire domain of the function. So let's take a look at an example. Again, we kind of talked about this one already. We've got a maximum, we've got a minimum as well. We also want to identify where it's increasing and decreasing. So usually it's easier to start off with your max and min because then you can use those points. Again, we're going to be doing intervals along the x-axis. You can use those points to determine your intervals for increasing and decreasing, because again, it increases up to your max and decreases down to your min. So we've got a max, again, this is a relative max at the point -2, 4. And we have a relative min down here at the point 0, 0 at the origin. So again, like I said, now we can talk about where it's increasing. It's going to be increasing up to that point and increasing after the min. So it is going to be increasing on the interval from -infinity up to -2. Again, we're looking at the x values here, and we're going to union that with from 0 to infinity. So again, remember your interval notation there. And we are going to be decreasing on the interval from -2 to 0, that remaining piece that was in between there. We're going to use open intervals here because we can't be increasing at a point, so it's always going to be open intervals. But again, you can see how we've got that -2 and 0 are our points that are our endpoints of our increasing and decreasing intervals. Okay, so I want you to pause the video here and try this next example, and then resume the video to check your answer. So this one does not have a maximum point. It kind of levels out here at the y-axis, but it doesn't actually have a maximum there. And there's a minimum though. The minimum here is at 3 and maybe -22, -23, depending on where you kind of follow the line over. It's, you know, there's no exact line there, so we've got to interpolate. And then it is increasing from our min, so increasing on the interval 3 to infinity and decreasing down to that point from -infinity to 3. To look at a couple more examples, we are going to use our calculators now, so go ahead and get those out. We are going to just plug in this formula here, y equals, we've got x to the 4th minus 8x cubed plus 18x squared minus 6x plus 2. Again, check everything, make sure you didn't miss anything. That looks right. We're going to hit graph. It might take a second. And you can kind of notice that our graph goes off here. We can't quite see. There's something going on up here we can't quite see. So we're going to adjust our window. We're going to go in here. We'll leave our x's okay, but we're going to scroll down to our y's so that we can be a little bit higher. And you should have noticed that the graph didn't go below the x-axis, so we can just start at 0, and then let's maybe go up to 15 and see what happens. Again, you can kind of see you've got the axis down here, and hey, we've got that point here. So you've got a relative max there, you've got a min here, and a min here. And again, we've got a relative minimum here, and we have an actual absolute minimum down here, where this is the lowest point of all. So to use your calculator to find this, you go into second calc. You've got these options for minimum and maximum. We'll try to find our absolute minimum there first. It's going to ask you for a left bound and a right bound. Again, it's looking in an interval. Since there's two minimums here, it needs to know which one it's looking for. So we'll go a little bit to the left, we'll scroll over a touch, go to the right, and if you get close, if you want to guess, it asks you, again, it depends on your calculator, sometimes it asks you this, sometimes it doesn't. It just helps it calculate a little bit faster. And so we end up with a minimum at the point 1.8996 and the y value 1.456. So we'll write that point down. Again, this is our absolute minimum, and our point is at 0.190 if we round to 3 significant digits, and 1.46. So I want you to pause the video here and try to find, again, using those features in your calculator, I want you to find this maximum here and this minimum. So again, looking here, you should have been able to calculate your other minimum here. Was it about 3.64 and 8.37, 8.38? And then we've got a relative max. Again, it's not an absolute max. It's just a relative max because it goes up to infinity on both sides. And that is at 2.168 and 14.17 about. Again, that gives you your max and min. You can find your increasing and decreasing intervals. So this is increasing from your absolute min, so 0.190 up to your max, so 2.168. And then we union that with, after your second min, 3.642. And up to infinity. So again, you're increasing from this point here up to your max, and you're increasing from your second min, your relative min, up to infinity. You are decreasing then from negative infinity until you get to that absolute min of 0.190. And then after your max, 2.168, down to your relative min, 3.642. So again, those are your intervals that you're looking at. Try a couple more examples here. This one is a square root, and so again, we know with square roots that our lowest point is going to be where that square root ends up giving us 0 because we can't have any negatives. And then 0 times, the only thing that could potentially be an issue is that t outside. Let's look at the graph real quick. I've already got this one in the calculator, so we'll just go over to graph. And again, it just looks like it goes straight up there. Again, if we plug in 4 here, we can see that 4 minus 4 is 0, times anything is going to be 0. And so that means that t is never going to, again, be negative to make this a negative. So our lowest point here, our absolute minimum, is at the point 4, and if you plug in 4, like I said, you get out 0. So we know that for a fact, and then it's increasing on that entire interval, everything after that. So it is only increasing on the interval from 4 to infinity. It's never decreasing, it's just increasing after that. That's what a square root does. Last example here, we've got an issue here with that 2 over x. That's going to give us an asymptote. Again, I've already got this one in the calculator. You always want to be careful with fractions. In this case, we just have single elements in the numerator and denominator, but if you have more than one and it's combined with addition and subtraction or even multiplication, you have to be careful that you use parentheses. So we'll graph that. And you'll notice here that this window that we had before isn't the best. So we're going to go back to zoom, and we're just going to zoom standard, so number 6. And now we can see the whole graph because part of it was missing before. So we've got a max somewhere about here and a min, or a relative min, somewhere about here. Again, we're not going to have an absolute in this case because we're going to positive and negative infinity along that asymptote. So again, pause the video here, practice using your calculator to find the max and the min, and then resume the video to check your answer. So we got to be really careful here with our increasing and decreasing. We'll talk about that in a second. If we just talk about the relative max and min, this thing is symmetric, which is nice because if you find the max, which was at negative 2.45 and negative 1.36, then you can just get rid of the negative numbers because you see that it's rotationally symmetric, and we'll talk about in the next section about that. That these are going to be the same values, just different signs. So the same magnitude, just different signs. So again, those are max and min. Move this over here so we can see it. We are going to be increasing again from negative infinity up to that maximum point, and then again after the minimum up to infinity, and then we are decreasing from that maximum point, so that negative 2.45. We've got to go to 0 and then break it up because again we've got that asymptote there, so then we're going to be going from 0 down to the minimum at 2.45, and so those are our intervals where we're increasing and decreasing. Hopefully this gives you a better understanding of increasing and decreasing functions as well as relative and absolute extrema.